So I found this in my spare parts bin in the shed. And this is an OVP relay. Many of you might be familiar with these. At the heart of these OVP relays is a zener diode, as illustrated by that symbol there. Off the top of my head, the value of that zener diode is that it starts conducting in the reverse polarity around 22 volts. So any voltage spikes above 22 volts get shunted straight to ground. If they're a persistent fault above 22 volts, that results in blowing this fuse here if there's more than 10 amps available with that voltage above 22 volts. And that will protect the connected control units that are supplied by the OVP relay. On KE-Jet cars, that's going to be the KE ECU and the ABS control unit, possibly some other things as well. Without looking at the wiring diagram, I'm not sure at this point in time. So that's why you get one of the most common complaints with KE-Jet cars. Randomly, I have difficult starting, black smoke possibly, running rich. All these kinds of things can occur when the OVP relay is faulty, because the KE-Jet ECU is effectively not even powered up, and the injection system is running in fail-safe mechanical only mode with no lambda control. So that's not ideal. Now, the most common issue with these is actually bad solder joints inside. So I'm going to open this up and have a look at it. As you can see, this is a virgin unit. It has never been opened before. We just need to fold these two tabs backwards and we'll have a look at what that looks like inside. So I carefully used the precision flat blade screwdriver to pry out those tabs there. And in order to pull this out of the can, you do need to remove that fuse, which I don't think I'll be able to do with one hand. So I'll do that off camera and come back. There is supposed to be an O-ring around this to seal the elements out of the top of this OVP relay, but really it's got a plastic cover anyway. So if that O-ring has deteriorated like this one has and completely gone missing, it's not the end of the world. Well, I was able to pull the fuse out, but I'm not going to be able to pull the relay out of the can with one hand. So I'll do that off camera and show you the result. So that is now pulled out of there. I did use pliers, pulling on the pins of this to actually slide it out. And you can see there's actually a hydrogen vent in the top there. And there is some kind of sealant that's poured in there when it's new, and it sticks the whole thing in there, so it's actually quite difficult to break that free. Sometimes it ends up completely destroying that can, but I got away with it, fortunately. Yeah, these tabs will fold back quite nicely. This insulative sheet goes over the board. Make sure that goes back on there when you have finished resoldering the board. This one doesn't look too bad, but I'm going to redo it anyway. Things aren't totally great with this relay, as in the solder joints. I just noticed these two joints here that go to the actual coil on the relay do actually have cracks forming around them. Obviously the coil does run quite warm when it's powered on for many hours at a time, and that's what's causing those solder joints to crack. I would have thought that it would be the high current traces with the bad solder joints on them. On this one, that's not the case, but I'm going to redo them all anyway, with plenty of flux and new fresh solder. So we'll have a look at that after I have completed the job. So I've used my vacuum desoldering station to remove the solder from all of these joints, and I have done them all again from scratch. Unfortunately, I can't find my flux. I don't know what has happened to it. It's just disappeared off the face of the planet. So I've just relied on the flux core in the solder that I have. It's done a reasonable job, and I expect this to work fine. I'll just reinstall the insulative sheet before putting this in the can. Out of interest, I will check the functionality of the zener diode before putting it back together. I can easily do that with a bench power supply directly connected to the diode itself, and crank the voltage up to 22 volts and beyond and see when it starts conducting. And yes, I did clean off all of the flux residue with isopropyl and a toothbrush. So I have connected the zener diode up to my bench power supply in reverse polarity. At 21.5 volts there is no current draw. As soon as I start going over 22.1 or so, it starts drawing current, or allowing current to pass, I should say. And progressively that increases the higher I go. We don't want to do this too long and destroy the diode, but you get the point. As soon as it starts going over 22 volts, it starts conducting in order to protect the circuits that are protected by this device. And that's already getting warm, so we don't want to do that for too long. Yeah, so that diode is working fine. Of course, assembly is a reversal of disassembly. Just once again, don't forget the insulative sheet when you are sliding it back together. It can only go one way. Make sure the contacts for the fuse are in the correct location, which mine are. And then you can just close it. And once again, fold these tabs over so it's sealed. There are other versions which are crimped around the entire outside. Those are going to end up looking ugly no matter what you do to them. So if you're lucky and have one of these, you can have the same outstanding results as myself if you're very careful folding those tabs out. So I'm just going to press those back in off camera and show you what it looks like. So there you go. I have crimped those down using the same pliers that I used to pull it out of the can. Just using the tip of that to fold it back over. So that's looking quite nice. It could almost pass for one that's never been opened, but we'll always know. And don't forget to put the fuse back in. This one's still good. I believe this relay still worked anyway, but this is just a bit of preventative maintenance. I have a feeling these are getting more and more difficult to find because everyone seems to have them on back order at the moment with no ETA for replenishment. So possibly the silicon shortage has something to do with the production of those diodes, or they might have just gone out of production. I don't know. So everyone might end up having to do this at some stage. So on the right we have the other style of OVP relay, which has the unfortunate design of being crimped around its entire perimeter. This one has already been resoldered, not by myself. This was fitted to my blue-black car when I got it. I didn't like its appearance, so I went ahead and bought a brand new one. It does work though, so it's handy for an emergency.